Hello and welcome to Real Civil YouTube channel. In this video, we are going to discuss a very important test, or we can say a semi-destructive test, that is core sampling and testing. So we are going to see different points related to this test. So let's get started. Here you can see the core cutter equipment. So this is the core cutter equipment. Then this is the actual process of extraction of concrete core using core cutter, and these are the core samples. So we are going to discuss this test in very detail. So first, core sampling and testing. In this test, we generally extract a cylindrical core from the existing structure, and then we test this in laboratory. Okay, now, so why do we extract and test core sample? So here are the main objectives: to determine the compressive strength of the existing concrete. Then we can carry out chemical analysis, petrographic examination of the concrete. We can determine the physical properties like density, thickness of the layer, bonding characteristics. We can even identify the defects, hidden internal issues like segregation, honeycombing within the material. I hope you know the segregation, honeycombing, like materials are segregated, they are not homogeneous. So you can detect. For this particular testing, we required one equipment called core cutter, and that with diamond impregnated bits. Here you can see this is the core cutter machine, and you can follow IS 516 Part 4 2018 for more information related to the core cutting and sampling. Now, very important part, that extracting a core isn't just drilling a random hole. There are strict site guidelines you must follow under IS 516 Part 4. So let's see. The core cutter should be rigidly placed, and it should be drilled perpendicular to the surface. As you can see in this picture, this should be rigidly held, and this should be this is the surface, and this is the perpendicular direction. Core should be preferably taken from the middle portion and not near the edges, corners and joints. So you should avoid taking the core from edge, or you can say uh, like corners or joints. You should go with the middle portion. Then you should avoid drilling through the reinforcement. So you should avoid the drilling, avoid the reinforcement. Then you have to avoid the flaws like locations with micro cracks, and you should preferably, or your target zone should be the compression zone. We know the tension zone, compression zone in the beams, columns. Now, very important, or you should keep in mind the factors like core size, slenderness ratio, location of core extraction, reinforcement, curing condition. All these may affect your results. Okay, so results are affected by these factors. Now, some more information related to the core. Uh, Here you can see the core sample. Here you can see core sample, and this is the diameter of the core. I can show again here. This diameter should range from 100 mm to 150 mm for nominal maximum aggregate size up to 20 mm. So if 20 mm aggregates are used, then you can take 100 mm to 150 mm diameter, and the core length to diameter, that is, here you can see once again, this is the length, okay, and this is the diameter. So ideally that ratio should be equal to 2, that is L by D ratio, that is core length upon diameter. That is, this is, suppose this is the cylinder with diameter D and this is the length, okay. So this is vertical length and this is diameter D. This ratio should be equal to 2. If the ratio is less than 2, then you have to use some correction factors. We will discuss the formula in the next slide. After taking the core, your surface should be grind to make the surface flat and parallel for testing. Because whenever you take the core, the surface is uneven. So you have to make the surface flat using grinding. Then very important, your core need to be capped with calcium aluminate cement mortar or sulfur sand mixture before testing. Okay, so that the load should be uniformly transferred. You need the capping, as you can see. You have to cap the surface. Remember, calcium aluminate cement or sulfur sand mixture before testing, and the core should be tested in saturated condition. Here you can see one core. This is your cylindrical core, and this is being tested in compression testing machine to check the compression strength. So the guidelines are, whatever rate of loading is there, that should be 14 Newton per mm square per minute. That is the rate of loading. That means our load applied is gradual, not a sudden load. The formula is simple. Compressive strength is whatever maximum load taken divided by cross sectional area. And very important, you should note the failure pattern, because IS code has given some guidelines related to the failure pattern, and in which case you have to consider this as a satisfactory failure mode, and in some cases, cases are there which are unsatisfactory failure mode. In that case, you need to revise the test. So that's why it is very important that you should note the failure pattern. This is the compression testing machine. I think you all are familiar with this. As I told you that in last slide here, correction factor. So let's discuss what is correction factor. So correction factor based on core diameter for cylinder compression strength. If the diameter of the core is 75 plus or minus 5, then we use the correction factor 1.03. And if the diameter is less than 70, then correction factor is 1.06. So these are direct, or simply you can use this formula for the correction factor F, which is equal to 0.11. This is basically for diameter, and this formula is basically for L by D ratio. Okay, so the formula is 0.11 L by D plus 0.78. So as I told you, if your L by D ratio is equal to 2, if you put 2 here, then it is 0.22 plus 0.78, that is F is equal to 1. That means for L by D ratio equal to 2, no need to apply any correction factor, or it is basically comes out to be 1. In other cases, you can calculate. Very important point, because we generally test the cubes on site for quality control, and here we are taking the cylindrical sample. So how to correlate the cylindrical strengths with the cube strength? So the equivalent cube strength of a concrete can be determined by multiplying corrected cylinder strength by 5 upon 4. So if you want to calculate cube strength or equivalent cube strength, then whatever results you got from cylindrical strength, you have to multiply this by 5 upon 4 factor. So you will get the results in terms of cubes. Okay, and this is our last slide, core sampling and testing related to the unsatisfactory failure of the core and satisfactory failure of the core. Okay, so you can see these figures are given in IS 516 part 4, uh, 2018, the unsatisfactory and satisfactory failure modes. So basically, clean diagonal cone and cap type shear fracture across the cylindrical show that the loads were evenly distributed. Means basically we want that load should be evenly distributed, and that failure pattern, as you can see here in satisfactory. So generally it is like this is the satisfactory failure modes. Okay, but these types of failure modes are uh, unsatisfactory, like they are cracking from one end or from the edge or from the corner. So likewise failure modes are there. Then code says these are unsatisfactory failure of the course. You have to revise the process, because in these cases we cannot consider the compressive strength whatever you got. So you have to keep an eye on satisfactory failure of the course. The examples are given. So I hope the concept is clear. If you have any doubt, you can ask me. Please like, share, subscribe the channel. Thank you so much.